Alrighty, in this video, we're going to actually go ahead and implement our ability to send data back to the client. Now, fortunately, we have tests to be able to do this with. And again, that was a big part of this framework, and this is going to be the first time where we'll actually be able to write out tests for a potential feature and then implement it based off of those tests. So you guys will be able to see an exact use case of how I want this system to work, along with the accompanying tests to do so, and then we'll actually figure out the implementation. Now, a lot of it is actually already pretty much figured out. I mean, our server already does the serialization of our results, but we haven't done any deserialization in the client yet. It's going to be a little tricky because we'll have to instantiate some generic types, which isn't always that much fun, but yeah, we'll go ahead and we'll get that implemented. So jumping into our test project, let's jump to our end-to-end namespace, our isolated namespace, and then our systems tests. What I'm going to do here is I will go ahead and create a new region called test component 2, and I'll say with responses, or methods with responses. I'll go ahead and do an end region here. Okay, so we're basically going to do the same thing where we'll create the 4 classes that we need, or the 4 types that we need. We need 2 interfaces and 2 classes. So let's start with our server. I'm going to say isolated component. Now I'm going to make it public. It's important that these interfaces are public, otherwise the dynamic proxy won't be able to create them or extend from them. And we'll do itest component 2 server. So what do we want the itest component 2 server to have? Well, we're basically going to be testing 2 cases. We're going to be testing a case where we have a RPC response without a result and an RPC response with a result. So I'm going to say iRPC method, which comes from the BuzzMMO base infrastructure namespace. Make sure that you include that at the top of your file. And then I'm going to say method without result, and I'll have a Boolean here called should fail, or how about should succeed? I always like doing positive booleans. And then we'll have an RPC method of string, and we'll call this method with result, and a bool should succeed. Okay, let's go ahead and implement our server interface. So I'm going to say isolated server system as an attribute, so our auto scanners or our assembly scanners pick up on it. I'm going to say public class test component 2 server inherits from client system base of type isolated player dot isolated player server, itest component 2 server as the server interface, and then itest component 2 client, which is an interface we haven't yet created. And then it's also going to implement itest component 2 server. So inside of our test component 2 server, we're going to be required to implement 2 methods. Our iRPC method, method without result, bool should succeed. Now, it'll be public as well. Now, what will this method do? Well, basically, all it's going to do is return a result. So I'm going to say if should succeed is true, then return RPC result dot success. Otherwise, return RPC result dot fail and pass in an operation error of operation error, which we'll test for in our tests. Then we need another public method, iRPC method of type string, method with result with a bool should succeed. If should succeed, return RPC result. Now this is important. We're going to return RPC result of type string dot succeed. And then we're going to pass in a result of result string, which we'll test for in our tests. Otherwise, we'll return an RPC result of type string dot fail, passing in operation error. And so that's our method without result and our method with result, showing a use case for either of these circumstances. So you can imagine, for example, our method with result might be a login method, where on success, it might return data about the account, like your account ID, your player ID, all that fun stuff. And then we have a failure, which we just return a list of errors. Okay, let's go ahead and do our client side now. So that's our server side. Let's do our client side. I'm going to do isolated component as an attribute. I'll do public interface iTest component to client, and this is going to be empty. Then I'm going to have a isolated client system with a public class test component to client, which will inherit from isolated client system base, passing in iTest component to client or server as the first interface and iTest component to client as the second interface, and of course it'll implement iTest component to client. Now this class is going to be empty. There's nothing that we need to put in the test component to client because again we're really just testing the server and how the base framework handles all this fun stuff. Okay, so now what I want to do is, so how do we test this? Well, basically, we need to gain access to the proxy object that's created for our isolated client system base. But that's going to be problematic because I made it protected. That was actually a poor design decision on my part. Our isolated client system base should have a public proxy object. The reason for that is it allows our tests to gain direct access to the proxy object of our client system for testing purposes. So let's go ahead and make that change real fast before we actually go about writing our tests. So what I'm going to do is I'm going to go to infrastructure and I'm going to go to isolated client system base tick2, and I'm going to come down here to its tserver proxy, and I'm simply going to change it to a public tserver proxy get private set. So it'll be a public property, a public read-only property, as opposed to a protected field. This way our tests will have direct access to it, and it'll make testing a whole lot easier. Alrighty, so let's go back to our systems test, and let's write some tests. So basically, in order to get this to, or to see if this is going to work, we need to do a couple of things. We need to write basically 4 tests. We need to invoke this method twice, one with it succeeding, one with it failing. Then we need to invoke this method twice, one with it succeeding, one with it failing. So we're going to write 2 tests. So coming down here, let's go ahead and write a test. Let's do the basic, most basic form first. I'm going to say public void invoking IRPC method on server succeeds. Sure, why not? It's a terrible name, but whatever. So I'm going to say var server equals new isolated server context. I'm going to say var player1 equals server.connectPlayer. Then I'm going to say player1.server.systems.create test component to server. So we're going to go about actually creating the test component to server on both the client and the server. Then I'm going to retrieve the test component to server from the client. So I'm going to say var client system equals player1.client.systems.get, and then based on the concrete type, we'll pass in test component to client. And now here's where the fun part happens. Now we have to go ahead and say client system.proxy, and now we can invoke our method with result. So I'm going to say method with result should succeed true. Now, what I need to do here is I'm going to create 3 booleans. I'm going to say bool did succeed equals false, did fail equals false, and did always. Or how about 3 integers? Int success count equals 0, fail count equals 0, always count equals 0. So we have 3 integers to keep track of which one of the results get invoked. So now we're going to do client system.proxy.method with result. Then I'm going to say .done, or sorry, it's method without result. Done res goes into success count plus plus. Then dot fail, res goes into fail count plus plus, and then dot always, res goes into always count plus plus. And then I'm going to say success count dot should be 1, fail count should be 0, and always count should be 1. And so that'll make sure that our callbacks are being invoked properly. Now remember, since this is all single-threaded, all in memory, the callbacks will be invoked synchronously. So we don't have to worry about any synchronicity because it's all happening in memory and in process. Okay, so let's go ahead and do our second test, our public void invoking IRPC method on server fails. Var server equals new. I could copy and paste. I'm going to copy and paste this. Okay, let's take this whole test, copy and paste. However, I'm going to change a couple of things. When we invoke method without result, I'm going to set this to false. Then, on my success count, I'm going to say should be 0, and on my fail count should be 1. So remember, we're wanting to make sure that the fail callback is being invoked at least, or exactly 1 time, and our success count is being invoked exactly 0 times. Okay, so, okay, actually we have to do a little bit more work on our on-server fails, because we have to make sure that our operation errors are set properly. So what I'm going to do is I'm going to say var operation errors equals enumerable.empty string. Then on always, I'm going to break this out into a multi-line lambda, and I'm going to say operation errors equals res.operation errors. Then down here, I'm going to say operation errors should let's see here. Should be same as, I believe this one. An object reference refers to the exact same object. No, that's not what I want. I always forget these ones. Equivalent to, expects the current collection to contain all the elements of the collection regardless of the order. Okay, sure. So we'll say should be equivalent to, and then I'll pass in operation error as the string. All right, so that's our invoking IRPC, which this should be capitalized, method on server fails. Now let's go ahead and say, write a new test, public void invoking IRPC method with result on server succeeds. Var server equals new isolated server context. Again, this is really important that we do this, because if we ever go out and actually change the implementation of this at all in any way, it'll be very nice to have these tests written. So say player 1, we're going to connect it, then we're going to say player 1 dot server dot systems dot create test component to server. I'm going to say var client system equals player 1 dot client dot systems get test component to client. Then I'll say int success count equals 0, fail count equals 0, always count equals 0. Then I'm going to say then I'm going to say var result equals string.empty. Then I'm going to say client systems dot proxy dot method with result should succeed true. Then I'm going to say done. Res goes into success count plus plus. Result equals res.result. Then I'm going to say dot fail. Res goes into fail count plus plus. And always res goes into always count plus plus. Then we're going to say success count should be 1. fail count should be 0, always count should be 1, and result should be result string. All right, so I'm going to copy and paste this entire method and write the fail version for this. So I'm copy and pasting the entire method, test method, and instead of onServer succeeds, it's going to be onServer fails. With result, I'm going to remove result and instead have var operation errors equals enumerable.empty string. And then I'm going to collapse done into a single line lambda. And then on fail, I'm going to say, or how about always? Always, I'm going to break out to multi-line lambda, and I'm going to say operation errors equals res.operation errors. And then I'm going to say success count should be 0, fail count should be 1, always count should be 1. And then I'm going to say operation errors should be equivalent to operation error. And that's it. So those are our 4 test cases. Now you might be wondering why I'm doing this up here. I'm saying var operation errors equals enumerable empty of string. Why am I setting operation errors to anything? That's because lambdas don't guarantee that an object is set. If I were to instead have done IEnumerable of string operation errors, I would get a compiler error when I tried to access it. That's because lambdas don't guarantee that the lambda... When you pass a lambda into something and you hoist a value into that lambda, you're not guaranteeing that that lambda will ever be invoked. Therefore, the compiler can't know for certain that the operation errors will have its value set to anything. I could do equals null, but that's kind of ugly. So instead, I just do var operation errors equals enumerable empty string instead. I think that's a little cleaner. Anyway, fun stuff. And those are our tests. Let's go ahead and run them and see what happens. Most likely, everything is going to break. None of these tests should succeed, I don't think. Nope. Okay, so what's our error? Key not found. The given key was not found in the dictionary. Where was that? Our system invoke ID was never found. Oh, that's interesting. Let's go ahead and debug this because it looks like we've already uncovered a bug. Set a bug right there. Okay, let's look at parameters. Count 2, we have a byte. So again, this is invoking a method on a system. The parameters that we passed in don't seem to include a system invoke ID because a system invoke ID is going to be 2, right? Yeah, so we have 0, 0, which is weird. Why would we have that? Okay, let's back up and see what's going on. Invoke method on system. This is our client context. We have our in-memory transport. Okay, so now we're in client code right here, our send operation with code 2 parameter. Okay, it looks like we invoked this from our send operation that doesn't have a callback on it for some reason. And the reason for that... Oh, there we go. Okay, so it looks like we found the first place that we need to go in and actually add some code in. So I'm going to jump all the way back to our tests here for a second, in case you guys want to pause the screen or something and look at what I've implemented, because I'm pretty sure these tests are all going to be just fine. But these 4 tests basically describe the entire functionality of our system. So let's get to implementing it. Starting off, we need to go all the way back into our client code, our client systems. And remember our proxy, how we have this interset method? We need to invoke a different overload on the operation writer. See how it's just doing invoke method? We need to do something different if there's a response. So what I'm going to do here is I'm going to say if method dot result type return type equals void, then invoke method. Otherwise, we need to do something interesting. We actually need to instantiate one of our objects, and we need to set the return value of the method invocation to that new instantiated object. Remember our deferred RPC method? Well, we need to return that basically. So as you'll see, inside of our system tests, we need to return something when we invoke something on the proxy so that we can invoke the done, the fail, and the always methods on it. And that's going to be our deferred RPC response. So what I'm going to do is I'm going to say else if method.returnType equals response, then I'm going to say var deferred equals new deferred RPC method. Then I'm going to say invocation dot return value equals deferred. Then I'm going to say operation writer invoke method, passing in the mapped method, passing in invocation dot arguments, and then passing in a on response. And the on response will simply be deferred dot set result. So we're going to literally invoke the set result method on the deferred object when we return when we receive a response. Now the next one's going to be a little trickier. So I'm going to say else if method.return type equals response with result. So this is a little bit more complicated. The first thing we need to do is instantiate our typed deferred RPC method. So I'm going to say var deferred equals, this is where things get fun, type of deferred RPC method without specifying any generic parameters. That's important. Dot make generic type, and then I'm going to pass in the method dot result type as the generic type. So I'm going to call this deferred type. Then I'm going to say, deferred type with one F and two R's. So then I'm going to say deferred equals activator dot create instance deferred type, because remember the deferred RPC method doesn't have a constructor. Then I'm going to say operation writer dot invoke method invocation arguments, and then deferred dot set, cast to deferred RPC method deferred dot set results. So this is why it's important that our typed or our generic deferred RPC method inherits from deferred RPC method, so we can cast it here and then invoke the set result method on it. All right, so let's go ahead and run our tests again and see if we got any closer or further away from our goal. Expected 1, but found 0. Okay, so this actually could quite possibly be a race condition. See, the way things are working now is everything's done in memory. So immediately when we invoke the method right here on our ICE systems operation writer, it's actually going to literally invoke the in-memory server, and the in-memory server is going to immediately send the response. Hopefully you guys can see where I'm going with this. Basically what's going to happen is in this particular test scenario, the set result method on the deferred RPC method will be invoked before we invoke the done, fail, or always. So that just exposed a actual potential design problem with the way the deferred RPC method was written. And that is, what happens when you get a result back for your deferred object before you've added the callbacks? So let's go ahead and address that right now. Let's go into our base infrastructure, deferred RPC method, the base type, and let's fix that. So what I'm going to do is I'm actually going to go ahead and at the top of the file, I'm going to say private RPC result, right? So we can cache the result once it was sent in. Then on set result, we'll have our invoking our done and invoking our fail. And then what I'm going to do is at the end of it, I'm going to say result equals result. Then on my done method, what I'm going to do is I'm going to say if result does not equal null, meaning set result has already been invoked on this object. Then I'm going to say if result does not equal null, then if result dot is valid, invoke on done immediately, and then return this, not even bothering to add it to the done actions. So now we're saying if you've already given us result, then immediately invoke that. So then we're going to do the same thing with fail. I'm going to say if result does not equal null, if not result is valid, then invoke on fail, passing in result, and then return. And then on always, return this. Then on always, I'm going to say if result does not equal null, on always, passing in result, and then returning this. Okay, so let's go back to our unit test sessions and run them. I don't expect this to change at all. It shouldn't change at all. And it doesn't. Okay, so we're getting expected 1 but found 0 on our test. And it's happening right here. Fail count should be 1, right? So unfortunately, these aren't being invoked. So what I'm going to do here is I remember I did put in to-do comments for things that we needed to wait until we started implementing the system to implement. So I'm going to open up ReSharper, and then I'm going to open up, what's that window? To-do items. Oh, we have a lot of to-do items. Oh, it includes not implemented exceptions, doesn't it? Okay, so... Okay, so it seems that we need to go ahead and implement... The final thing to implement are these two. These two final to-dos. Okay, let's implement the easiest case first, the response that does not have a result. So what I'm going to do here is I'm just going to simply say var response equals new RPC result, passing in is valid and operation errors. Of course, so remember our is valid that we extracted out of our parameters dictionary up here? Remember, we're in Systems Operation Writer. I should probably have pointed that out. So we're in System Operation Writer under buzzmmo.client, and then we're looking at the parse response method. What I'm going to do here is we didn't cast is valid or operation errors into the proper types, so I'll go ahead and do that. I'll set is valid to a boolean and operation errors to an IEnumerable of string. Okay, so coming back here into this if statement, so if method return type is response, instantiate the result, and then simply invoke on response. In fact, we could just inline that variable. Invoke the callback, passing in a new instantiation of RPC result, setting if it's valid, and the operation errors. Let's go ahead and run our test and see where that gets us. Sweet. We got 2 tests passing. So we got the 2 tests that deal with invoking RPC method on server without results. So now let's do the with results one. So when we have the with results, what we need to do is we need to invoke this callback. We need to pass in a new instantiation of the RPC the RPC result of tResult, which means we need to instantiate a generic type, which is never fun. And then we need to pass in isValid, operation errors, and result into its constructor. I'm thinking an easier way to do this. Well, no, let's just see what happens. Okay, so the first thing is we need to construct a generic type for our RPC results. So I'm going to say generic RPC result type equals type of RPC result dot make generic type, passing in our method dot result type. Then I'm going to say var generic RPC result equals cast to RPC result, and say activator dot create instance, passing in generic RPC result type, and then I need to pass in a new array, or a params object array for the arguments to pass in. So I'm going to pass in them in order, which is valid operation errors and result. So is valid operation errors and result object. Then I'm going to invoke on response, passing in our generic RPC result. Still have a warning somewhere. Oh, I don't care about that. All right, so this completes that bit of logic. Let's come back here and run our tests and see what happens. Failure. System null reference exception. Oh, right. I don't think on our... Okay, so we've done that bit already, but now we have to go back to our client systems. And, yeah, I forgot to set the return value of the invocation. So what's happening is this invocation right here is returning null. We want it to return with an implementation of IRPC method. So let's come back to our client systems class in our client assembly, and let's go to the if statement with response with result. And then at the end of this, or how about before I invoke operation writer, I'm going to say invocation dot return value equals deferred. Now let's go ahead and run our test again. All right, so we got a success on one of them, but a failure on the other. I'm willing to bet I just messed up the test a little bit. I did mess up the test. I invoked method with result passing in true, but this was our fails test. So let's change that to false, because remember, that's the should succeed. And that's it. So yeah, that's pretty much our ability to send results back to the client. So now on our components, we can simply return RPC methods and then have our client depend on whether or not those things succeeded or failed. Let's go ahead and just wrap up this video with a just a fun little thing, I guess. Maybe. Okay, yeah, just a fun little thing, I guess, just to watch this work with our real code. So I'm going to go ahead and launch Photon. Well, before I do that, I'm going to hit F6 to perform a build. I'm also going to make sure that I'm on the right configuration, which I am on Debug Nelson, good. And then I'm going to go ahead and start up Photon. While Photon's starting, I'm going to go ahead and start up Unity. And then while Unity's loading, I'm going to go into Base. Oops. I'm going to go to Base, Components, System, Login System. And I'm going to add a new method to the server. I'm going to say IRPC method int do something bool should fail. All right, so we have an IRPC method that returns an integer and has an indication if it should fail. Since we've changed the interface for our server, we'll have to go into our server master, systems, and hop into our login system and add that method. So we have our do something. The thing I wanted to return is a count of how many times do something has been invoked. So what I'm going to do is I'm going to add a private field after our log. I'm going to say private int invoke count. Then on do something, I'm going to say invoke count plus plus. Then I'm going to say if should fail, return RPC result dot fail. Something bad happened. Otherwise, or sorry, RPC result of int fail. Otherwise, return RPC result of int dot success, passing in our invoke count. Let's go ahead and compile that by hitting F6. Now let's open up Unity. And let's go into our login system. And I'm just going to put together a really quick interaction thing in here while we wait a million years for Visual Studio to start up. Again, you guys don't have to do this if you don't want to. We'll be clearing out all of this stuff when we actually implement the login system. But for now, we're just doing some simple stuff. Okay, I'm going to say I'm going to go ahead and give this some private data. I'm going to say private int call count. Then I'm going to say private IEnumerable of string, or I'm just going to say private string error string. Then I'm going to say public void on GUI, GUI layout.begin horizontal, GUI layout.end horizontal. Then I'm going to say if GUI layout button fail. Then I'm going to say proxy dot do something, or sorry, yeah, do something true dot, and then I'm going to say fail res goes into error string equals string dot join comma on res dot operation errors dot to array, which of course will require a link. And then I'm going to say if GUI layout button succeed, proxy do something false dot done res goes into call count equals res dot result. Then I'm going to say GUI layout dot label call count GUI layout dot label errors error string. And that gives us some basic interaction logic to work with, so we can watch things happening. Okay, let's go up to Unity, try to get it to focus, but it doesn't want to. And jump into our scene, our loader scene, hit play. Oops, I forgot that I destroyed the system, didn't I? At the end of that whole count thing. What I'm going to do here is I'm just going to on the server in our login system, I'm going to remove the line that destroys the client server. Then I'm going to do a rebuild. Give it a few seconds, then hit play. All right, so let's do succeed. And we get an error. Let's do fail. And we get an error. Okay, cannot cast from blah 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 to blah blah blah. Systems operation writer. Let's see here. Systems operation writer, display class, parse response, operation code. I wish it... Why doesn't... Okay, so it seems that we do have a slight problem somewhere. It says cannot cast. So let's jump into our client system operation writer. Let's figure out what it's complaining about as far as a cast. Now, what's interesting though is it's doing this for both success and failure. It's probably not able to cast this, because that's the only thing I can see that's casting anything. In fact, I'm going to go ahead and comment that out and invoke onResponse with a new RPC response, new string, or new... Okay, so I'm going to comment that out to see if that's really the cause. I'll hit F6 to do a rebuild. Remember to always hit F6 to do a rebuild when jumping between Unity and our Visual Studio project. Now let's hit play. We still get cannot... parse response. Okay, so I'm still getting an invalid cast. Is it my result bytes? That's the only other thing I see that I'm casting. Okay, let's comment out more code. Hit F6 to do a rebuild, jump back into Unity. Wow. This is really persistent. Okay, let's think about what exactly we're casting here. Our operation errors, maybe? Oh. I'm willing to bet that's the problem. Yeah, that has to be it right there. Okay, so I'm going to go ahead and remove all this garbage that I... That's weird. Or is it the Boolean? No, you can pass Booleans with Photon, or you better be able to. Let's just isolate that real fast. Again, I'm just... See, debugging Unity stuff is really not that fun. It's really not my favorite thing to do in the world. Okay, so it's not the Boolean. Let's just ensure that it's the operation errors. I'm going to say enumerable dot empty string, and then I'm going to comment out that cast. Do a rebuild with F6. Jump back over, hit play. Well, that worked. So what does it want us... Oh, I think it... No, it wouldn't have done this. I better not fix it. Or it might actually fix it, and it actually kind of sort of makes sense if you think about it. Okay, good, it didn't fix it. Okay, so now what we do, the easiest way to debug this, or the best way to kind of debug this stuff, when we have all this code in Visual Studio, we're building it out to an assembly, we're stuffing it in Unity, then we're running it. One of the best ways to debug this sort of stuff is to use logging. So up here, I'm going to say private static read only ilog, bring in log for net, log equals log manager get logger, type of systems operation writer. Then what I'm going to do is I'm going to change this back to how it was before. Actually, I'm going to say cast to IEnumerable string, because I could have swore that worked at some point. Maybe I just have a terrible memory, which I'm pretty certain I do. Okay, what I'm going to do here is I'm going to say log.info format, or just info, and I'm going to do parameters at byte operation parameter dot response operation errors dot get type dot full name. So I'm going to log out the actual type of this data to see exactly what type it is, so I can get an idea of what's going on here. Okay. Let's hit fail. It's an object array. Okay. Well, that makes things easy. So I'm going to do operation errors. What I'm going to do here, and you guys are going to want to do this on your own too, I'm going to cast it to an object array. Then I'm going to wrap it, and I'm going to say dot of type string dot toList. which will convert it all to or it'll extract all the objects that are a string out of it, and then copy it to a new list. Now, in theory, this will work. We got here, hit play. And it works. So I get both success and failures. Let's actually clean up the client code a little bit. I only want to have one of these invocations of do something. So what I'm going to do here is I'm going to say var should invoke equals false, var should fail equals false. If they hit the fail button, I want to say should invoke equals true, should fail equals true. If they hit the succeed button, I want to say should invoke equals true, should fail equals false. Then I'm going to say if should invoke, then proxy dot do something, passing in should fail, and then I'm going to say dot done. Res goes into call count equals res dot result. Dot fail, res goes into error string equals string dot join, comma on res operation errors dot to array. And then dot always, res goes into debug dot log did fail plus res is, so is valid, res dot is valid. So this, all the code that we've written in the last few videos comes down to being able to do this. So we have our success condition, if the invocation worked, we have our fail condition, and then we have our always code. Let's come back here into Unity, hit play. And it just works. We now have cool stuff written. Alright guys, well, it took about an hour-ish to put this feature together, but I think it was worth it. So now we can retrieve results from the server. And that's really important. It's really important to be able to know if the server operation succeeded or not. But it's also really important to be able to get data back. Like, for example, if we do something with our inventory, we might want to get some new ID back for the slot something's in, or just something in general. But this allows us to do that. So, yeah, cool stuff. I guess we'll see you guys in the next video.